Okay, we will move to the next topic, that is forcing functions. Forcing function. What is forcing function? Forcing function, that is the input function, any input function of the process that changes the stability of the system, that we can say the forcing function. There are four basic type of the forcing function that we have to study is the step input, impulse input, ramp input, and next is the sinusoidal. These are the four basic forcing function that we have to study in the PDC, and the forcing function are those that tends to changes the stability of any process or the system, right? So step input, we will study the transfer function for the different inputs, different type of inputs. It's the transfer function. So what is a step function? A step function f of t is represented by is equals to ut, and its Laplace transform f of s if it is of magnitude a. So this will come like a upon s. A is the magnitude of step input. A here is magnitude of step input. Impulse function f of t is represented by del function of B. Say if A is the magnitude of your impulse, so its Laplace transform, the Laplace transform of del function is 1. So its Laplace transform for the impulse function is A. Next is the ramp input. Ramp input. The function for the ramp input f of t is equals to a t, where a is the slope here, and its function, its Laplace transform is a upon s square, where a is the slope here in case of the ramp input. If we go graphically, the step input is represented like this, and this is the magnitude A. If we are talking about the impulse input, this will go at some finite time like this and this. So this is the magnitude of your impulse A, right? Or we can say like this. It's a single line. Ramp input. The graphical for the ramp input, it will go linearly, it rises linearly with respect to time. So this is the slope of your ramp input that we have denoted here by A. And the sinusoidal input f of t is equals to a sine omega t, where a is the amplitude here, and the function Laplace transform of this is a omega upon s square plus omega square. So if the sinusoidal wave is here, so this one is the amplitude A. We can say this is your amplitude A. Omega is the radial frequency. Omega is radial frequency. And this is nothing equals to 2 pi f, and f is nothing but 1 by t, where f is cyclic frequency and t is the period of oscillations. So this is all about your forcing functions and its function representation, transfer function and its graph. If we take the example of the step input means you have opened up the tap for some certain amplitude. You have given some amplitude to your system and remains there. Open up your valve. Impulse input, you have opened up the valve and just closed it in a fraction of seconds. But that is practically impossible. So you can say for a finite time we have opened up the valve and closed it. Right? So that is the example of impulse input. Either you are injecting something in your reactor. Right? That is also the example of impulse input. And the ramp input, that is varies linearly with respect to time. For example, you are increasing your oven temperature by 10 degree Fahrenheit at every 10 minutes. So you can say that is an example of ramp input. So note down these forcing functions in its transfer function and few graphical representations. After this we will see few graphical representation for the different type of functions. So I am drawing few graphs for any function t to the power n u t. The graph will go like this, and that is factorial n upon, we know the Laplace transform of this is factorial n upon s to the power n plus 1, or either it can be s to the power n. If e to the power minus at is given, if function e to the power minus at is given, then its graph e to the power minus at means decreases exponentially. One thing, the step input and one more step input and the sinusoidal function, both are the bounded functions. Step function and sinusoidal, these are the bounded functions, and these are unbounded functions, that is impulse and ramp. These are the unbounded forcing functions. And generally the step function, the bounded forcing function, the function that has certain boundaries, that are said to be the bounded forcing function, and bounded forcing function are said to be for any system is the stable system. Means bounded forcing function is said to be the stability, means that represents the stable system, or unbounded forcing function represents the instability. If function f of t is equals to t to the power n into e to the power minus at, means initially increasing then decreasing exponentially. Initially increasing then decreasing exponentially. Right. Next, we know the sinusoidal wave. How does it go? Like this. If it is sine hyperbolic kt, and its transfer function is nothing but, we know it's k upon s square plus k square, but in this case this will go like this. k upon s square minus k square, that is sine hyperbolic kt. That will not go like this by like t to the power n, this will go like this, like wider, much wider, like this, k upon s square minus k square. The bounded forcing function are the step amp function and impulse. Because you do not know up to where that impulse will go. You do not know from where this curve will go. But these have certain boundaries. That is one cycle, another one cycle, and that is step for up to a magnitude 1. That is, if its response curve we draw, this will go it's up to its ultimate value AKP, and it will remain under there. But this is not the sufficient condition to set about the stability of any system. This is an idea, we can say, and to check the exact stability we have to perform other tests like Rouse test and other stability tests, right? Should I erase it? Yes, this is F versus time domain. We are expecting everything here, or we can say the output with respect to the time, or f of t with time. All the graphs are with respect to output to the time. We know cos kt. The curve goes like this from here. So its hyperbolic curve will go after few phase lag from here. Similar like of cos sine hyperbolic kt, but with some we can say this intercept as intercept rate. You just not read to remember, you just have a rough idea how does the graph go. Many a times match the followings they can ask. So if you have 2-3 graph ideas, you can match easily. And you know very well how does the sine kt graph goes, and sine hyperbolic kt goes with quite wider. You know t to the power n means t square or t somewhat goes parabolic or somewhat goes like this, right? And everyone knows e to the power minus at means exponentially decreasing. Exponentially decreasing will go like this, right? And if we are adding this t to the power n to our st, increasing then decreasing. These are very easy graphs, right? But this is the end of the graph. One more graph is when we add e to the power minus at into sine kt. So you just think, how does the graph go? Sine kt, sinusoidal wave, e to the power minus at, decreasing amplitude, means sinusoidal wave with decreasing amplitude. Cos hyperbolic kt, this is hyperbolic, not hyperbolic, it's kt only. E to the power minus at into cos kt. We know that this will start with a phase lag or with some phase angle, as compared to sine lag, this will go like this, and similarly with the decreasing amplitude because of e to the power minus at. Okay, we will take one example here. We will solve one question, gate question. The question is, graph is given to you xt versus t, right? 0, 2, 4, 6. This one is 1. So you have to take the Laplace transform of the input function st given in the figure below, given that is given to you the input function for input forcing function. It is given to you. You have to calculate the Laplace transform for this. The graph is given to you. So what you have to do to write the Laplace transform? What is Laplace transform? Yes, because cos hyperbolic kt or either sine hyperbolic kt, it is like we can write it as e to the power minus at plus e to the power 80 something like that divided by 2. This comes like something like that, exactly I don't remember. And similarly cos hyperbolic kt, right? When the plot is graph is plotted, few points are being considered, but the final graph comes like this. Yes, to calculate the Laplace transform of any function, if it is given to you, from where you should start to solving the question? You know what is the Laplace transform? The Laplace transform of any function f of t. Here we are talking about the xt, we can write it xt. Laplace transform of any function xt is represented by integration of 0 to infinity xt into e to the power minus st into dt. That we have defined. This is the Laplace transform of any function, right? That we have. This is the Laplace transform. Given to us is the graph. So we have to calculate from the graph is what is xt. We have to calculate xt from this graph. What is xt? So you will calculate xt here like when your time t is less than 0, means t is less than 0, you can say either at this steady state condition or before the any disturbances given to the system is at steady state, or we can say the value is 0. When time t is greater than 0 but less than 2, greater than 0 but less than 2, see the graph, this is looks like a ramp input, right? So for this you can write it as AT. For the ramp input, you write it as AT. A is nothing but the slope. So you have to calculate the value of slope here, A. Then you substitute in this. Again, after t, graph is going after t. When t is greater than 2, graph is constant. So our function here is the final function. When t is greater than 2, this is constant at the value of 1. So these are functions for this curve that is given to you. By initial value theorem, graph by axis intersect at 0. Cos hyperbolic kt intersect at 0, 1. I'm not getting your point. At 0, cos hyperbolic kt. How you are applying the initial value theorem in this? Because the cos hyperbolic kt is nothing but k upon s square minus k square, right? If you are taking s common, how you can apply the initial value theorem in this? I'm not getting your point. Okay, let me recheck this. We will move to the another topic. If I will found anything is wrong or anything to elaborate, I will elaborate you by tomorrow. But that is started from here. Because if we go to the trigonometry, we know the sine and the cos that will have a difference of phase angle by 90. Okay, let's look at this question. So substitute the values of xt in this function. So how does it comes? For less than 0 is 0, for 0 to 2 it's at. 0 to 2 it's at into e to the power minus st into dt plus from 2 to infinite. This is 1 into e to the power minus st into dt. So this is how you get the equation. Now you just solve this integration, you will get your Laplace transform of the function, that is xs. One plus 1 divided by 2 is equals to 1. So it will start it from 1. It will not start it from 0. Right? It will start it from 1, not from 0. Right? Okay. So that is, I think clear. It will clear to you now. Okay. So you have to solve this question. This is the integration part. You will solve this by integration by part. This one is take it as first. This one take it as second. I think everyone can solve this, or should I solve this? And this one easily simply integrate this, and you will get the solution for this question. This type of 2 questions being asked from last gate year questions. This is the gate question. So should I solve it further, or I have provided you function, only the calculation part is there? Okay, just try to solve and tell me the final answer. Okay, I'm solving the question. This will come like xs is equals to, in the integration by part, we take it like at first, we take first that will, after differentiation, try to make it 1. So after first differentiation, that t will turn to 1 and e to the power minus st, it will not goes to 1. We know that it not have the final solution. We take it as second term. So in this, take first as it is. You calculate the value of slope a. How to calculate? By 2 minus y1 upon x2 minus x1, that is 1 by 2, right? That is 1 by 2. So here we write it as 1 by 2 into, first remains as it is, e to the power minus st upon minus s, 0 to 2 minus integration of 0 to 2, integration of the differentiation of the first term 1 by 2 into t, the differentiation of t is 1 into e to the power minus st, integration of the second term upon minus s into dt, plus 2 to infinity, or directly integrate this, e to the power minus st upon minus s, limits are from 2 to infinity. When you solve this, you will get the final result, xs is equals to 1 upon 2s square into 1 minus e to the power minus 2s. Do you get this answer? Have you got this answer? 1 by 2. Okay, yes. So one more question that is similarly being asked, only the values are changed here, 0, 3, 6, 9, and here is 0.3. You know the concept how to write the function xt, then substitute the values and you will get the result. Okay, transfer function. Okay, now we will move to the subject, more towards the subject. What is the transfer function? It is transfer function. Suppose this is a process given to you, any process. We represent it by G, P. P is for process. Here is some input is given to the process and output to the process is by T. Right. So the transfer function of any process is defined as the Laplace transform of the output to that of the Laplace transform of input function. That is ys upon xs, and that y and x should be in the deviation form. What is the deviation variable? Deviation variable is represented by the capital letter. Deviation variable is represented by the capital letter, and it is defined as the difference between the process condition at any particular time minus the process condition at the steady state condition. This is the deviation variable. Means, yes, yt0 take 2 in x2 because we take slope less than 2 minutes. No, slope we are not taking. Slope it is calculated like dy by dx. If the graph is given to you, you have to calculate slope for this. This is the y-axis, this is the x-axis. So the slope is y2 minus y1 upon x2 minus x1. So that is you have to calculate it slope, that will come 1 by 2. That is 2 here, 1 here, 0 here, right? So 1 y-axis y2 1 minus 0 we have taken, y2 at respectively 1, that is the value of x2 is 2 minus 0, that is 1 by 2, and we have taken 0 to 2 because that ramp curve goes from 0 to 2. After 2 it will constant from 2 to up to infinite time, right? So that is taken to 2 to infinite. Yes. So this is the deviation variable. Deviation variables means you have initially you have your thermometer at steady state condition, right? At say 30 degrees centigrade. That is, you are saying that initially your thermometer is steady state at 30 degrees centigrade. After certain time, you have given step input of 10 degrees centigrade, means that will goes to output of the 40 degrees centigrade, right? So your thermometer will not get exactly the 40 degrees centigrade, it will be less than that of the 40 degrees centigrade. That is your the process temperature at that time. The value of your that temperature, it may be 38, it may be 37, it may be anything. So the difference between the process condition at any particular time t minus the steady state value is termed as the deviation variable. That is called your deviation variable. Yes. Do you get your point? Why we taken 0 to 2 in 80? Less than 40, because there are few losses. As we have given input, exactly we are not getting the output. That is the losses that we have tried to achieve. This is the control system. We are controlling this. Means the input that we are giving, exactly output that will give. When we discuss the first order system right now, that we will discuss why not the 40%, because exactly we will not get, few losses are there, few heat losses are there, and some time taken will be there. We are taking like for if you are making tea, then it will take time to boil, and we are taking like it will take time 5 minutes to boil. We are taking a time t is equals to 3 minutes. So it will not reach to the boiling point at t is equals to 3 minutes, because it boil at t is equals to 5 minutes. We are taking at any time t xt, right? And when it will remain at any constant temperature, maybe it 40, maybe it 39 point something, that condition we will say the steady state condition, right? Okay. So this is the Laplace transform of output function to the Laplace transform of input function, that is ys upon xs. That we said is as the transfer function. Transfer function ys upon xs. Next is the time constant. Time constant. Time constant is represented by tau, and it is defined as the product of resistance into the capacitance. Resistance into the capacitance. That is the time constant. Yes, steady state value will change with time if you given to the disturbance. If you have not given the disturbance to the system, system is operating at steady state condition. You have not given any disturbance to the system, any load you are not giving, any step change you are giving, any change input forcing function you are not giving, then it is not possible to change the steady state condition. But practically it can change. Practically it can change, but theoretically it cannot change without any disturbance. Practically how it can change? There are some environmental conditions and certain other conditions because equipments are there, right? So equipment failure occur and certain other things may be changes. So in that condition, steady state condition change, but theoretically it cannot change without any disturbance, without any forcing function, but practically it can change, right? Yes, time constant is defined as the product of resistance into the capacitance. Now, we will move to our processes, that is first order system and the second order system. First order system. The example of first order system are, we have done with the derivations. We will discuss here only the transfer function and its response with respect to different forcing function and equations that are being used to solve the questions being asked in the GATE examination. So we will discuss the important formulas, topics and few questions based on that. And if there anyone having any doubt, you can ask. I will explain you elaborately. Okay, the first order system, mercury thermometer. Another one is liquid level system. Next one is the mixing process. Another one is heating system, water heating system or any heater system. One thing that is being asked, that is the time constant for these different type of processes. For mercury thermometer, this is mCp upon Ha, where we know all the values. What is m is the mass of the mercury, Cp is the specific heat of the mercury, H is the convection coefficient. Like in case of conduction it is K, in case of convection it is H. A is the contact area of the fluid to the thermometer. In liquid level system, tau is represented as area of the tank into the resistance offered to the bulb. In the mixing process, it is written as B by Q. V is the volume of the reactor, B is the volume of the reactor and Q is the flow rate. In case of water heating system, it is like volume. Let me check. It is represented by some. Rho B by W. Rho B by W. That is this one is kg per hour. We can say the mass flow rate, and another one is the tank volume. B is the tank volume. And W is the flow rate. Yes, for the heating process. Yes. Okay. So these are the first order system example and value of tau for the system. Just note down this one first. Okay. What is first order system? First order system are those that follow the first order linear differential equation. For example, if the system has the mathematical model equation like a1 dy by dt plus a naught by is equals to b xt. So we see this is the first order linear differential equation. So this type of model equation if we get from any process, then such type of system is called as first order system. Such type of system is called as first order system. And if this is of second order system, second order equation d2 by dt2 plus a1 d by dt plus a naught by is equals to b xt. Then we said this one is as second order system. This is called the second order system. Let's take the example. We will take example of liquid level system because we have to solve the formula. We have to solve the question based on that. Okay, I will erase in this. Okay, let's take mercury thermometer first because many questions are being asked from this from last years. So we understand what are the different variables on this. Mercury thermometer, that is an example of first order system. Suppose we will take a cross sectional view of the thermometer. By T is nothing but here is the mercury in thermometer. This is glass wall of the thermometer. This one is the fluid film to which we have to measure the temperature. So the fluid film, this is temperature having xt and the output temperature here is the, we are denoted it as by T. Right. So this is a thermometer. Suppose this is a thermometer, mercury is there. We are assuming the mercury is showing the temperature that is equal to by T. The output is over here is the measured temperature that is by T and input here is the fluid for which we are measuring the temperature, and this is at a temperature xt. For this we have to develop the model. For that condition we will take unsteady state energy balance on the system. How to take the energy balance? Rate of heat in minus out is equals to accumulation of heat. Accumulation of heat is nothing but the internal energy or the change in enthalpy. So before writing this, we have to take few assumptions in this case. In case of the mercury thermometer, what are that resistance? We say that all the resistance are neglected and the resistance that is offered only owned by the glass and the mercury is negligible, and resistance is offered only by the film surrounding the bulb. Means the resistance that is being offered, that is only by the film, and the film, from the film to this we say that is will go by the convection. The heat will go by the, and all the thermal capacity is in the mercury. Means at any instant mercury assumed to be the constant temperature. We are saying that any particular time t, we are assuming that mercury having the uniform temperature throughout the thermometer, and the glass bulb that contains the mercury, it will not expand or contract when come in the different temperature of the fluid. And after these assumptions, we will apply the unsteady state energy balance to the system. So rate of heat in here is only by the convection, or that is by HA into input is xt minus by T. And here is nothing is output here, only here is the accumulation of energy, and that is will represented by your temperature. So it will 0, and accumulation of heat is nothing but by mCp delta T or dy by dt. That is because it was unsteady state energy balance and it is varying with time. mCp dy by dt. Right. So this is the equation that you have developed for unsteady state energy balance for this cross-sectional view of the thermometer. In order because you want to write the transfer function for the first order system. So how to write the transfer function for any system? You first take either the unsteady state energy balance or the material balance to the system. Then you will get an equation. Then you will solve. By T denotes here the output temperature here by denoted by the mercury, means this is your mercury thermometer, right? You have dipped in a particular fluid, right? I want to measure the temperature of this room environment, right? Open environment. When I put this in the room, here are the certain room temperature is supposed to be 50. Means how the mercury will read, right? Few resistance will be offered. We have neglected here the resistance offered by the glass, and so we assume only the resistance offered by the film of the fluid film here. So by T is the temperature that will show in the thermometer, or you can say the output temperature, your measured temperature, or you can say the output temperature. By T here is the output temperature or your mercury temperature. Okay. So this is the equation that you have written at any time T. Similarly, write this equation at any steady state condition. When your system thermometer is at steady state condition, means after a particular time, after a certain time, that thermometer attains such environment and it remains constant at that particular value. So steady state energy balance equation. This one is the unsteady state. So at steady state condition, we will report the the input temperature as xs into T minus y s into T is equals to, that remains 0, m Cp. At steady state condition, if we differentiate any constant, that will comes to 0. Either you write it as 0 or either you will write it as d by s by dt by dt. We have written it as because we are making some formula. So we have written it as d by s by dt, or it will be 0. It can be 0. So the next step is, this one is equation 1. This one is equation 2. We have to write first equation in terms of the deviation variable. What is deviation variable? If we are talking about the x, then x, capital X is equals to xt minus xst. So we will take equation 1 minus equation 2. After taking deviation variable, you can take the Laplace transform. So this will comes like HA xt minus xst minus by t minus by st is equals to mcp into d by minus by s divided by dt. That is nothing but, all these are the deviation variable. You can write it as HA x, either xt, you can write it as xt minus by t is equals to mcp d by dt. Right? Write down. It can be written as xt minus by t is equals to mcp upon ha, divided here into d by dt. Right? We have term, this term is as tau. So this will come xt minus by t is equals to tau d by t by dt. This by is nothing but the function of t. Right? Now you have first order linear differential equation. Right? Alright. You have equation like tau d by t by dt plus by t is equals to xt. That is nothing but, this is first order linear differential equation, and the system that follow first order differential equation is known as the first order system. Right? So take the Laplace of this equation. We know this is not easy to solve any differential equation. So we take Laplace transform to solve such type of equation. So take the Laplace transform of the equation. This will come like tau. The Laplace of differentiation is tau s by s minus tau by 0 plus by t is nothing but by s is equals to xs. By 0, what does it indicate? By 0 means at time t is equals to 0, and at time t is equals to 0, we know that at steady state condition the deviation variable will be 0, because by is nothing but by t minus by s, and this is saying at time t is equals to 0 means at time t is equals to 0, this is also at steady state condition, means by s minus by s, this will come as 0. So this comes like, take by s as common, tau s plus 1, this term and this term is equals to xs. And we have to write the transfer function. What is the transfer function? Transfer function is defined as the Laplace of output to the Laplace of input. Output here is the by t, input is xt. So by S upon XS, that is we have represented it as by GS, is equals to 1 upon tau S plus 1. That is nothing but the transfer function for the first order system. Transfer function of first order system. Which area? The area that is in contact with the bulb, the outer side of the mercury. That is the area. Surface area of the bulb that is in contact with the film. Okay, so write down this. This is the transfer function for the first order system. Okay, now from this, what outcome we get? After so long calculation, what we obtain? What is the result? What is the conclusion? The conclusion is the mercury thermometer obey the first order differential equation, so it is the first order system. First conclusion we can say. The second conclusion we can say the first order system having the transfer function like 1 upon tau s plus 1. Right? Now, the another conclusion is when we represent this transfer function in time domain. When we represent this function in time domain, then we will check for different type of forcing function, how does the output will vary. Like if you are having thermometer, you are putting this in a certain environment, like you are putting to measure the temperature of certain fluid. So you have dipped in a particular temperature. So how much time it will take to reach the steady state condition, or how much time will it take to attain at particular temperature or at particular value? How? Let's assume you are giving certain forcing function step input. Forcing function means certain step input. Input here is xs, and we have discussed for step input what is the value of xs is. If you are giving is of magnitude a, is this will be a upon s. That is a upon s. So substitute the value of xs in this first order system. So you will get by s is equals to a upon s into 1 upon tau s plus 1. You will get this equation. From this equation, you want to convert this equation into time domain. So what we have to do? You have to take the inverse Laplace transform of this equation. You have to take the inverse Laplace transform of this equation and you will calculate the by t. What is by t? What is by t for this? For that purpose, you will take the partial fraction first and calculate the value of a and b constant. Then you will take the inverse Laplace transform, and that it will come equation by t is equals to a. Here we are not comes like ap. In many cases, the steady state gain is there. Steady state gain, we will discuss it. So this will be Kp, that is steady state gain of the process, into 1 minus e to the power minus t upon tau. That if you are having Kp here, in few equations you have some constant with xt like k, p, r, anything. That constant we represented at a steady state gain as a constant value, and that it will be represented in the output. But for the simplicity, we are solving with one. Take it here only a. By t is equals to a into 1 minus e to the power minus t upon tau. Or you can write it as a kp into 1 minus e to the power minus t upon tau. Now, from this equation, you know the value of a, the magnitude of step input. You know what is t at any particular time. You want to know the value of your process, and tau is the time constant. By t here is the output temperature, right? So I am giving you one question. Just try to solve that based on this formula. That is simple formula based question. Question is a basic question. A thermometer of time constant now given. The question is, I am giving you the value, just try to solve. A thermometer of time constant is denoted by tau, is 10 seconds. Is initially at 30 degree centigrade. Initially 30 degree centigrade means this is given at any steady state value. This is given any steady state value by S. I am representing you all the symbols, then it will be quite easy for you to calculate. Otherwise, you have to choose from the question what is by S, what is Y, and what is the other value. So here by S given is as 30 degree centigrade and is suddenly immersed into water bath at 100 degree centigrade. Means at any particular time it was immersed into 100 degree centigrade. Initially it was 30 degree centigrade and it is immersed in 100 degree centigrade. 100 degree centigrade means how much amount of step input? 100 minus 30. That is the value of A is 70 degree centigrade, right? How long will it take to reach the thermometer reading at 90? The question is asking how much time will it take so that thermometer will read 90 degree centigrade, means after how much time. So it is given by t is as 90 and they are asking about how much time, after how much time you have to calculate t. All the variables are known to you. By capital by t we know it's a deviation variable, it is nothing but by t minus by s. A is the amount of step input that is given to the process. In this question all the values are given, t is given. In many questions it can be asked like it is given to you the time, means after 10 seconds how much it will show the reading, how much it will show the reading after 10 seconds. So in that case t is given to you, you have to calculate by t, right? In many cases they have asked directly to the deviation variable. They will ask what is the output value, what is the output value shows in the thermometer, that is your by t. Most of the cases that output at any particular time t by t is being asked, it can be asked any of the constant. They can given you the final value of by t, they can give you the time value at what time, they can ask the value of time constant, what is the time constant for that particular process, they can ask you the time constant. So solve these questions by substituting all the values. Of any doubt in this question you can ask. or should I take the another similar question? Yes, what is the value of this T? By this time, I must suggest you must follow the gate calculator, must have your hands on the gate calculator, your virtual calculator. Don't use Casio or your phone calculator. Phone calculator means the gate calculator used for gate examination. You will download the app, because that is nothing. You will simply touch, and that is being simply is like you are using calculator. Because in your PC you have to move your finger or mouse in order to tap the value. Yes, anyone is there solving the question? This is nothing but 90 minus 30 is equals to 70 into 1 minus e to the power minus t. We have calculate upon tau is the 10 seconds. This is the simple equation. You have to calculate t from this equation. That is nothing but 90 minus 30 is 60. Or this will become 6 by 7 is equals to 1 minus e to the power minus t by 10, or e to the power minus t by 10 is nothing but 1 minus 6 by 7 is nothing but 1 by 7. Just take the logarithmic on both the sides. E to the power minus t by 10 is equals to 1 by 7. Solve this. No, x input is cannot be the initial value. Initially they are saying the thermometer is initially at 30 degrees centigrade. Initially at 30 degrees centigrade means they are talking about the steady state condition. And after that they are saying after certain time, after this 30 degrees centigrade value, we have immersed the thermometer in an environment of 100 degrees centigrade. Means initially temperature reading was 30 degrees centigrade. We have put it into a glass like that have a temperature of 100 degrees centigrade, right? So what is the magnitude of step input? Look into the graph. Initially it was at 30 degrees centigrade, right? And they are saying suddenly it is immersed to 100 degrees centigrade, right? So what is the amount of step input here? 100 minus 30, right? 100, that is the amount of step input given is this one, that is 100 minus 30, right? Do you get your point? Temperature of x is denoted by x, but here is not x is given to you, right? The output temperature be denoted by x. Understand from here, from x. You are confused with x. X is here, right? X is nothing but it's an input. Input given to the system, that is any forcing function. It can be step input, it can be ramp input, it can be any input. They are saying that we have given the thermometer in 100 degrees centigrade, right? In 100 degrees centigrade means in temperature, they are not saying they have dipped and picked it out. They have said we have put it in 100 degrees centigrade. Means it's an example of step input, right? So we have substitute the value of excess step input into the your first order system, and that is your response equation is this by T for the step input, right? Okay, I will write down all the equations. You will get more clear idea. First understand this. So your by T is equals to A upon 1 minus e to the power minus T upon tau. Your XS will comes in this A upon S that we have taken is XS. Or A is the magnitude of your step input. And step input is nothing but that is this magnitude 100 minus 30. Right? This is the temperature that we are denoting here. I am making you understand. Don't get confused by on the y-axis. If this one is just like this is a glass initially at 30 degrees centigrade. Thermometer is dipped. Thermometer reading initially at 30 degrees centigrade. It is dipped in 100 degrees centigrade water. You understand why this? In water, right? So it will rise from 30 to 100. So the magnitude of step input for this process will be 100 minus 30. Why are you getting confused? The magnitude of step input A. Here we are taking step input. XS is the input to the function, right? You are saying XS is the input to the function. I am agreeing this is the input to the function. And the Laplace transform XT. Laplace transform of XT is XS for the step input is A upon S, right? We are again converting it into the Laplace transform time domain. From your differential equation, we are converting into is again to the time domain by taking inverse Laplace transform, and this the simplified equation that we get, right? So we are substituting the values of all the given parameters, and A is the magnitude of step input that comes from your XT or XS. XT is nothing but A into T. Not A into T, it is A into UT. That is unitary step function. No. Understand. What is step function? Step function, we have given certain reading and we have remained at there. Impulse, we have put it there and take it out. Just dipping and take it out. Or like you are injecting something into the reactor for a fraction of second. That is not calculated. In the question it is not given that it is dipped and taken out. It is only given that it is put into the environment of 100 degrees centigrade. They are not saying that we have taken it out. Right? So it is an example of step input. Not impulse input. They are saying impulse input, then they will say that they will put it and take it out. And in this case, this is the example. If you are thinking of ramp input is nothing but your temperature is increases linearly with time. Means like 10 degree Fahrenheit. If you are giving like any putted value to your oven, like at every 10 minutes it will rise to 10 degree Fahrenheit, or at every 5 minutes it will rise to 10 degree Fahrenheit. That will be the ramp input. But this is the example of step input. Okay, do you get? Yes. What is the answer? What is the value of T? The value of T is 19.5 seconds. Any doubt? Should I repeat again? Or do you get this answer? Should I move to the next question or should I explain this? Should I explain this again or move to the next topic? Okay.